Momentum and impulse, a comparison.
This is the momentum equation, where momentum equals the mass times velocity, and velocity is in meters per second, and mass is in kilograms.
This is the equation for impulse. As you can see over here, it's force times delta T, measured in time, in seconds preferably, and force is measured in newtons. Altogether this gives the impulse in newtons times seconds.
Oh! This is the impulse-momentum theorem. Impulse is the amount of force expressed over a given period of time, which equals the momentum final minus the momentum initial, or the change in momentum. And using the other equations, you can see that impulse equals the mass times the final velocity minus the mass times the initial velocity, which equals the mass times the change in velocity.
So now we're going to test one scenario of this impulse theorem. Our lovely assistant over here, Jordan, is going to take this block of Legos and toss it into this blanket. What this is illustrating is short distance, long time. As time increases, force will also decrease, and therefore this precious mass of Legos will not break. Let's see this in action. In this next scenario, we're going to describe short distance, short time. Therefore, impulse, because time will be shorter, force will increase, and therefore the Lego has a chance of breaking. Let's see this in action.
In the last two examples, we saw the blanket, which had a longer impact time and less total force applied, because if the delta T is greater, then that means the denominator is greater, which makes the whole force less. In comparison with the block of wood, we had less of a time of an impact, which results in a greater force, because if the delta T is smaller, that makes the equation end up bigger.